Oh boy. This is honestly evil. If you don't know the identity, then uh I oof. I don't know how you would speed your way into solving this. Okay. Well, so to start off with the identities, whenever you have cosine of inverse sine, this is actually equal to sine of inverse cosine, which is pretty uh, helpful because less memorization. So both of these, they equal to the square root of 1 minus x squared. So it's a very important identity to memorize because this occurs a lot in the integration bees. And then the other way around is kind of works the same way, except that it doesn't equal to the square root of 1 minus x squared. So this is equal to pi over 2 minus x. Now be careful. This is not always true. This is only true. Oh, well, I should probably the whole thing actually. This is only true at the interval of 0 to pi. Anywhere else this is not true. Okay. So this is definitely less than 0. This might be over pi. Is it over pi? I mean, 2 pi plus 2. That's pi. Wait. Yeah. 2 pi plus 2 over 2. I mean, is that over? I'll figure it out. But uh we're gonna have to sort of manipulate the bounds a little bit. So let's actually work on the bounds because that is important. I don't know why come on, work with me. Okay. So let's work on the bounds. So we have pi minus 1 and pi over 2 plus 1. Pi over 2 minus 1 is less than 0 because if I were to do pi over 2 minus 2, right? Oh, wait a minute. It's not less than 0? Pi over 2. Oh, shoot, I'm dumb. This is not. Wait, pi over 2 minus. Oh, no. Uh-oh. Okay. Well, I mean, at least it's less than pi. So, okay. Well, I'm wrong. I'm sorry. This is actually more than 0 because pi minus 2, this is pi minus 2 is positive because the pi is 3 point something minus 2. That gives us a positive number divided by another positive number, which means that this whole thing is positive. So it's greater than 0. Okay, cool. As long as it is less than pi, right? So we can make the bounds go from pi over 2 minus 1 to pi to the function we have, and then plus pi over 2 to plus 1. Now, to double check that this is greater than pi. So this is, let's see, pi plus 2 over 2. Let's compare it with pi. Shoot, how do I compare this to pi? Pi plus 2, 2 pi. 2 pi, this is like 6.28. This is like 5. Oh, shit. this is less than pi as well. Well, aren't you glad we double-checked our bounds? Because we could have been eliminated. Okay. Wow! Oh! Okay. So technically we just do nothing with the bounds then, as long as... Well, I mean, I'm glad that we checked, because we could have gotten the wrong answer. Cool! So in that case, we can apply the identity with no problem. So then pi over 2 plus 1. Okay. So then we do not need to split the bounds then. Okay. So then we can just freely say, well, it's pi over 2 minus 1, pi over 2 plus 1. So then in this case, this portion here, or if I can, this portion here, this is just pi over 2 minus x. So pi over 2, oh wait, was it cosine? Yeah. So cosine, inverse sine, and then this is just pi over 2 minus x. Cool. I'm going to do a u substitution, and you will see why. Well, actually, I guess I could just say, so I'll just tell you right now. So the reason why I want to do a u substitution, if I let u equal pi over 2 minus x, what happens is that I get my bounds to 1 to negative 1. Okay? So now that I got that u substitution, I can now go like this. So again, just a reminder, right? Then, well, my bound, the top bound was pi over 2 plus 1, right? So now if I plug this in to pi over 2 minus x, this gives me 1. So my top bound is 1. And if I apply the same thing with minus 1, wait. Oh, no, I'm sorry. No. Plus 1, this would be negative 1. So the top bound would be negative 1. And then if I do the other way, then it's plus 1. And then this dx, the du equal negative dx, this negative here will help me switch the bounds. And so that negative helps switch the bounds. So now I get back to negative 1 to 1. And then I get cosine inverse sine of u du. And then this portion, we already know this identity. This is equal to, 1 minus u squared, which equals 2 pi over 2. So if you don't know why this is equal to pi over 2, this integral is the area of a half circle. So to explain this answer, so this is also an integral that you should memorize. Whenever, well, yeah, so the answer is pi over 2. And let me just clear everything. Whenever you get something like the radius of a radius, and then radius squared minus x squared dx, right? Whenever you get this in a graph, this is pretty much what this is. So in the graph, you get this from r to negative r. Okay, this is just an area of a half circle. So literally, your answer is just going to be pi r squared over 2. That's it. Okay? If this was to 0, right, then you're only focusing on to 0 to r, which means that this is just 1/4 of the circle. So then this would equal pi r squared divided by 4, and you're done. So this is a very important integral to memorize. It's just the area of a portion of a circle, pretty much. Area portion of a circle. It has to be r squared minus x squared. If it's anything like x squared minus r squared or x squared plus r squared or vice versa, these two will not work. This is not a circle. This is something else, and you're just gonna have to do trig sub. Unfortunately, I mean you can memorize the formula for it, but it's not worth it because I guarantee you it's gonna be a long ass answer. So, yeah, and that's that integral here. So should be pi over 2, and it is pi over 2. Awesome. I thought this actually turned out nicer than I thought. Holy hell. I thought it was gonna be very ugly, like something, but no, I guessed wrong. This is actually nicer than I thought.